IGCSE 0652 with the code. We are going to study about the lecture magnetic field around a conducting wire. Okay, so through the understanding of a syllabus, details outline in this accompanying figure magnetic field around a conducting wire. When current flows through a conducting wire, a magnetic field is produced around the wire. So this is a best example in which we will get through the idea that what is magnetic field and how we can measure around a magnetic field around a conducting wire. Okay, this seems not that much difficult topic to you. It will be very easy. So before starting this lecture, do you have any idea about the magnetic field, Aryan? If you have, then explain.
A magnetic field.
Yes, magnetic field.
Well, it's the field between a north and south pole.
Okay, so magnetic field is produced between the two magnets, which shows some kind of attraction and repulsion, and because of that attraction and repulsion, that shows some kind of magnetism, and they produce a magnetic lines. Okay, so we'll dive into the magnetic field created around a conducting wire. This is an essential concept in electromagnetism, very important and very essential concept, because it's a fundamental to understanding electric motors, generators, transformers. So this is the base of, if we're going to study about the motor, generators and the transformers, this concept is the base of that lectures. This thing will tell us how the transformer, generators and motors works on this principle, on mutual induction, on electromagnetism. Okay, so let's start it. And various electrical devices. When electric current flows through a conductor, when electric current, now here is electric current is flowing. Okay, let me show you the arrows. Here electric current is flowing now. When electric current flows through a conductor, it generates a magnetic field around it. So it generates a magnetic field around it, and this phenomena is the basis of the motor effect and the principles of electromagnetic induction. So electric current and magnetic field. So by looking at this is a picture that describes. So I will elaborate this picture first, and then I will give you a brief explanation about this thing. Okay. So conducting wire, when a current flows through a conducting wire, a magnetic field is produced around the wire. The shape and the direction of magnetic field can be investigated using plotting compasses. The compasses will produce a magnetic field lines pattern that would look like the following magnetic field is made up of. For example, this is a paper and there is a conducting wire. When we place 4 different compasses on that paper, so that current is passing through that paper as well. We put here hole, a small hole nozzle. Okay, so when the current is passing in that conducting material, that current induced a magnetic field lines around itself. So that magnetic fields will be captured, will be seen by the rotating needles of the compasses. They will indicate the direction of the needles. Okay, so by using the needles, you can draw this on your paper as well. Okay. So circle as a distance from the wire increases, the circles get further apart, and this shows that the magnetic field is strongest closer to the wire and gets weaker as the direction from the wire increases. So when the wire is closed, okay, so this is listen carefully, the wire increases, the circles get further apart. This shows that the magnetic field is strongest closer to the wire. When the magnetic field is close to the wire, it will have a strong magnetic field lines. When the magnetic field is away from the wire, it will have a weak magnetic field lines. Okay. So we have to use right hand grip rule can be used to work out the direction of magnetic field. Thumb point along and the direction of current, the curled 4 fingers. Okay, curled 4 fingers telling you the direction of the current, and the thumb will show you the direction of magnetic field. Okay. So magnetic field thumb point along the direction of current and curled forefingers gives the direction of the field. Reversing the direction in which the current flows through the wire will reverse the direction of magnetic field. For example, in the front of picture, this can you make this hand right hand grip rule according to this? No, very good. Okay, if I change the direction of current, you have to move your thumb downward. Yes. Now look, direction of current is changed and direction of magnetic field is also changed. Okay? Okay, good. You can now we can continue. Current flows through the wire will reverse the direction of magnetic field, increase the amount of current flowing through the wire will increase the strength of the magnetic field. This means the field lines will become closer together. For example, if you just switch the direction, this is a direction, I change the direction of current in opposite direction. If I will receive the largest magnetic field line, it means that the magnetic field become closer to that current. If it will shows are lesser, then it means that magnetic fields are away from the current. Did you get the point? Okay. So by looking at these 3 points, when a current flows through a conducting wire, magnetic field is produced around the wire. The magnetic field lines pattern will look as circles around the wire, and the distance between each circle increases as further from the wire. Look, there is a first circle, second, third and fourth. So one by one circle is increasing. Circle is will not stop at any single point. They will increase continuously and continuously. Okay, so maybe when the circle are closed, so each circle is close together, close to each other, they have the strongest current, strongest magnetic field. If the circles have apart, have a larger distance, it means that they will have a weaker magnetic field lines. Okay. So after this, in the next page, I think I have the next point. Yes, reversing the current will reverse the direction of magnetic field. Increasing the current will increase the magnetic field strength, and this means field lines will become closer together. Okay. By looking at this, these are the look first point, second circle, third circle. These are close together, na? Close together. Last one is away from, away, na? So dot means out of the page and cross means into the page. So this is a description in which you describe each and everything. The dot is like that is inside the page. Dot is something that is inside the page, and the cross that is out of the page, and the cross is into the page. Okay, can you read this point, Ayan?
When a current flows through conductor wire and magnetic field is produced around the wire, the magnetic field lines pattern will look as the circles around the wire. Distance between each circle increase as further from the wire. This shows that magnetic field strongest closest to the wire and gets weaker after distance from the wire increase. Reversing the current will reverse the direction of the magnetic field, and increasing the current will increase the magnetic field strength. This means that the field lines will become closer together.
Good. Okay, and I hope you understood the concept as well.
Yeah.
Good. Now magnetic field around a solenoid. So we just did on a simple circuit, wire with the paper with the compass. The magnetic field it just not stop at this kind of experiment. We can use different kind of apparatus to show the strength of magnetic field in the relationship with the current. There's so many methods. So basically this is a single coil. Okay, look here, this is a single coil, and this single coil is attached with a circuit in which current is flowing. Okay, so solenoid, when a current flows through a wire that is loop, this is a solenoid. Solenoid means when we have so many turns of coils. Here I have single coil, here I have so many coils, and I call that as a solenoid. Okay, so wire that is looped into the coil, magnetic field lines circle around each part of the coil, passing through the center of it when current flows through the wire that is coiled to form a solenoid. This because this causes the magnetic field strength. For example, this is a current. Now current will start flowing to the each turn of coil. When the current is start flowing from this circuit, now let me use a different color that will shows which one, this one. Okay, look here, this is the coil, this is the number of turns of solenoid, collectively they are known as solenoid, one coil. The current is flowing here, current is flowing. When current start flowing to the each turn of coil, by passing from that, the current is induced, current will induce the magnetic field lines. Magnetic field lines like this, they are coming from one part outside going towards, and this kind of, they produce a magnetic field lines around the solenoid. Okay,
Yes.
and the solenoid, this cause the magnetic field strength to increase. Stronger the magnetic field strength, greater the number of field lines. Why? Because current is closer to the each solenoid, current is passing through the each solenoid, and each solenoid produce a magnetic field which is closer. Look, they are very close to each other, all of the solenoid. There is not a longer distance between these two. If I draw these two, these, all of them are close together. Close together, na? If they are close together, they have a larger current, they will have a stronger magnetic field. Okay?
Okay.
Strength greater the number of field lines, right hand grip rule can be used to work out the direction of magnet. Now, if I wanted to measure the direction of magnetic field here and the current, I will just put my hand around like this. Look, they use two methods. This one, this grip which shows the direction of, curly hand shows the direction of current, and the thumb is showing the direction of
Magnetic field.
very good. Look, you can see that the current is traveling in each part of that solenoid upward. Let me draw, if I can draw here. Okay, now current is traveling like this. Okay, this one, and I will use a different color to show the direction of magnetic field. This one, this one, this one, and this one. Did you get the point now, I am? The four fingers, the curly fingers, will show the direction of current. When you just grab that, okay, when you grab that solenoid, you will see the direction of magnetic field and current as well. Okay, now read these points.
Magnetic field pattern will look like the following. The magnetic field around a solenoid is similar to that of a bar magnet. The magnetic field inside the solidity is shown and form reversing the current direction versus the direction of the magnetic field. And adding more turns increase the solidity's magnetic field strength.
Okay, did you understand the concept of how the current is produced in single coil and the number of turns of coil? Okay,
Yes.
yes, and here as well, na? Look in this picture. If I circle this one, circuit, and current is flowing like this, straight line and this. Okay, now the electromagnet, and this is the next concept of electromagnet. Electromagnet, a solenoid can be used as electromagnetic by adding soft iron core. For example, this is the iron core inside this. This is iron core and this is solenoid and this is a current flowing switch is on. So there are different methods in which I can induce magnetic field with the help of current. Okay, and the first method is a simple circuit with the compass with the paper. In the second method, one number of coil, and then I can make a solenoid. I can induce magnetic field in that circuit as well. Now, this is again the solenoid, again the current, but this is with the iron core. Okay. So the electromagnet solenoid can be used as electromagnet by adding a soft iron core. The iron core will become an induced magnet. That will become an induced magnet. When current is flowing through the solenoid, the magnetic field produced. Look, now the current is start flowing here, and this magnet, that current will also go inside this iron, and that iron will become magnetized because of the magnetic flux it is receiving from the circuit current. Did you getting the point, Aryan? Ayan, sorry.
Yes.
Okay, from the solenoid and the iron core will create much stronger magnet. Overall in iron core is the soft magnetic material. It is easily magnetized. So iron core is a very soft iron. It get easily magnetized and demagnetize, allowing the electromagnet. So it can easily magnetize or demagnetize at the same time. Look here, iron core is a soft magnetic material. It easily magnetize and demagnetize, allowing the electromagnet to be switched on and off by turning the current on and off. अगर आपका ये करंट फ्लो कर रहा है, when you like switch on है ना, तो वो मैग्नेटाइज है. अगर आपने स्विच ऑफ कर दिया तो वो क्या हो जाएगा? डीमैग्नेटाइज. ठीक है. Magnetic field forms around the electromagnet when it's switched off. The field disappears, changing the direction of current. Also changes the direction of magnetic field. अगर आप उसकी करंट की डायरेक्शन चेंज करेंगे, फॉर एग्जांपल अभी ये डायरेक्शन की करंट इस तरीके से जा रही है ना, ठीक है, तो फिर आपके यहाँ पे देखें ना, वो इस तरीके से अंदर जा रहा है, यहाँ से वो बाहर निकल रहा है. अगर मैं डायरेक्शन करंट की ऐसे कर दूंगी तो यहाँ से वो अंदर जाएगा और यहाँ से वो बाहर निकलेगा. ठीक है. कैन यू ड्रॉ this circuit but with a different direction of current? ये ड्रॉ करके अगर आप मुझे भी दिखा दें.
Different directions.
यस, डायरेक्शन करंट की आपने बिल्कुल डिफरेंट रखनी है. अभी जो करंट की डायरेक्शन है वो तो ये है. अभी आप क्या करें, मैं आपको एरो बता देती हूँ. अब आपने करंट की डायरेक्शन को यहाँ से स्टार्ट करवाना है, ऐसे ऐसे लेके जाना है. अब आपको यहाँ पे
तो समझ नहीं आ रहा है सर्किट में why is it going from positive to negative.
आपको तो बताया था ना कि बेसिकली आपने अपने एग्जाम्स पॉइंट ऑफ व्यू के लिए याद रखना है कि करंट ऑलवेज स्टार्ट फ्रॉम नेगेटिव टू द पॉजिटिव. जब वो पॉजिटिव से नेगेटिव की तरफ जाती है तो वो कन्वेंशनल करंट कहलाती है. तो अभी कन्वेंशनल करंट फ्लो कर रही है. आप इलेक्ट्रॉन का फ्लो करवाएं, आप नेगेटिव से फ्लो करवाएं. ठीक है. इस सर्किट में बिल्कुल ऐसा सर्किट बनाएं और उसमें इलेक्ट्रॉन फ्लो की डायरेक्शन को फ्लो करवाएं. ठीक है. और यहाँ पे आपने ये भी चीज देखना, हर एक कोयल पे आपको नजर आ रही है डायरेक्शन, उस डायरेक्शन को भी फॉलो करना पड़ेगा. फील्ड प्रोड्यूस बाय द आयरन कोर स्ट्रेंथ ऑफ एन इलेक्ट्रोमैग्नेट. नाउ हम लोगों ने जो आयरन कोर प्लेस किया है, इट विल बी मैग्नेटाइज एंड इट विल प्रोड्यूस अ स्ट्रॉन्ग मैग्नेटिक फील्ड स्ट्रेंथ. व्हाई? Because it is like much closer to these solenoid, these coils. It will have a larger current, it will have a larger magnetic flux as well. Okay. So here are the next points in which a solenoid can be used as electromagnet by adding soft iron core. When current flows, magnetic field forms around the electromagnet. When it is no, this isn't a soft iron core. When we place inside the solenoid, that soft iron core will become a magnet. It will magnetize, switch on, demagnetize, will switch off. Okay. Changing the direction of current also change the direction of magnetic field produced by the iron core, and the strength of electromagnet can be increased by, this is on the next page, can be increased by increasing the current. These are the very important 3 points. Strength of electromagnet can be increased. For example, this is a magnet, no? This is an iron core. 1 minute. If we want to increase the strength of electromagnet, can be increased by these 4 important steps. Increasing the current. When we just increase the voltage, increase the power, the electromagnetism will be increased. Increasing the number of coils. If we increase these turn coils, they will have a larger flux. Adding an iron core through the center of the coil, like this. Okay. So the application of electromagnet. Electric relays used in electric bulbs, electronic locks and others, loudspeakers and headphones. These are the best example that shows electromagnet. Best example that we use in our daily life. Okay.
Okay.
Do you have any question here? No? Now I give you an example of electric relays. No? So we have to get the idea that what is this thing we use in our daily life. So electric relay is a switch operated by electromagnet. a small current flowing through one current circuit can be used to turn on the current in a much more powerful circuit. For example, this is a circuit 1. Okay, so in this circuit 1 we have a coil, we have a magnet, and we round that magnet with a number of turn of coils, and that is the current. This is a switch, is a circuit 1 relay coil. This coil is relay on the circuit number 2. How? Look, this is a low power supply and this is a high power supply. So describe the electric relay is switch operated by electromagnet using an electric relay. Small current flowing through one circuit can be used to turn on current in much more powerful circuit. Okay, when switch S1 is closed, a small current flows through the circuit 1. Switch S1 is closed, small current is flowing in the circuit 1. Did you get the point?
Yes.
So that small current induced magnetic field in the relay coil, and the magnetic field attracts the switch 2. It is now attracted towards the switch 2, causing it to open the circuit. To this allows a high current to flow in a circuit, to causing a light bulb to turn on as the temperature increases the resistance of a thermistor. Look, this is also known as mutual induction. When we have two circuits, another circuits do not have any source, any power. We just bring that circuit toward that circuit in which there is a voltage, there is a power, and there is a magnet. Now that magnet is induced, that magnet is covered by the number of turns of coil. When the small current starts flowing in that circuit, that coil's induced magnetic field. We know this now, how magnetic field is induced in a circuit because of the changing of current. Okay?
Yes.
Yes. And when current is transferring, moving, magnetic flux is induced, and that flux is transferred to the circuit 2, and that because of that circuit 2, that bulb will lights up. So when the current is transferred to the circuit 2, not the current, the induced EMF, the induced magnetic flux, okay, causing a light bulb to turn on, that bulb will lights up because of the current that is transferred from switch 1 to switch 2, and the temperature increases the resistance of the thermistor and the lights bulb will lights on. Decreases, this causes the current in the circuit 1 to increase the magnetic field it induced to the relay coil. If the first circuit has a low current, that low current will help us to induce a coil, induce the magnetic flux in the relay coil, and that will transfer the circuit 2. In the circuit 2 they will have a high voltage power supply. Okay, so if we increase, the stronger magnetic field attracts the switch S2, causing it to open the circuit 2. This allows a high current to flow in the circuit 2, causing the light bulb to turn, and electric bell relies. For example, they just took an example of bulb. If I place a bell on the place of a bulb, same things will go here. That bell will start ringing. Okay, and these are the all points. Can you read these points to get the better idea?
Right. Switch S1 is low, a small current flows. Circuit 1, when a magnetic field is induced in the relay coil. The magnetic field attracts this S2 positive to circuit 2. This allows high current to flow in circuit 2, causing a light bulb to turn on.
Yes.
As the temperature increases, resistance of thermistor decreases. This causes the current circuit to increase. A magnetic field is induced in the relay coil to increase. The stronger magnetic field attracts to S2, causing it to open the circuit 2. This allows high current to flow in circuit 2, causing a light bulb to turn on.
Yes. Okay, do you have any question in this, Ayan? Everything is good?
Yeah, it's good.
Very good. Okay. Now I am just exploring. We just exploring the examples, applications of induced current, the current is flowing and the magnetic flux is induced. How an electromagnet work around a wire, conducting wire. Okay, so this is another example, electric bell. We have this kind of bell in our schools now, and we always wanted to know when the pin click the button itself ringing, and the break time or the off time and the next period time. So we have to learn that how this thing will work. Okay, so electric bell relies on electromagnet to function. This is a structure. Let me do the zoom out. This is a structure, electromagnet, springy metal, and these are contacts. So when the button switch is pressed, a current passes through the, this is electric bulb. So जब हम स्कूल में जब लाइट होती थी तो ये जो पीएन अंकल इसको प्रेस करते थे और ये फिर ऑन होती थी, हमें पता चलता था कि नेक्स्ट पीरियड है. लाइट जब नहीं होती थी तो ये वाली नहीं यूज़ करते थे, वो दूसरे यूज़ करते थे, हैमर वन अ स्ट्राइक ऑन अ मेटल प्लेट. ऐसा ही होता है ना. ठीक है, तो अब करंट पासिस थ्रू द इलेक्ट्रोमैग्नेट. दिस इज द, अब आप सोचेंगे ये कैसे काम कर रही है, क्योंकि इलेक्ट्रिक बेल है, ये हमारे घरों में भी लगी होती है. ऐसा ही है ना. यस. सो ऑन एन इलेक्ट्रोमैग्नेट टू फंक्शन व्हेन द बटन इज pressed, a current passes through the electromagnet creating a magnetic field. This attract a springy metal causing the hammer to strike the bell. The movement of the springy metal breaks the circuit. अगर आप देखें ना तो इस बेल के अंदर भी एक सर्किट बना हुआ है. वो देखिए, वो मेटल के इर्द गिर्द जो है वो इलेक्ट्रोमैग्नेट उन्होंने बनाया हुआ है. कोयल्स हैं, कोयल्स को सॉफ्ट आयरन कोर के साथ लपेटा हुआ है, तो वो एक मैग्नेट बन गया. ठीक है, एक स्प्रिंजी मेटल है, जब आप बटन प्रेस करते हैं ना तो उसको थोड़ी सी एनर्जी मिलती है, वो आगे मूव करके उसको अट्रैक्ट करता है, फिर कॉन्टैक्ट, फिर नीचे जो बॉल है ना वो जोर से हिट करता है बेल को. अब वो कैसे करता है देखते हैं. So springy metal causing the hammer to strike the bell. The movement of springy metal breaks the circuit by separating the contact. This stops the current, destroying the magnetic field. So the springy metal returns to its previous position. This reestablishes the circuit and the whole process starts again. Okay. So look, this attracted the springy metal causing the hammer to strike the bell. When you press, a current passes through the electromagnetic. This is the current passing through this, and it produces creating a magnetic field. And this attracted the springy metal. Okay, this is a springy metal. Springy metal will attract that metal because of the opposite charges, na? And the movement of springy metal breaks a circuit by separating the contacts. So when they attract by hitting together, they break this contact. ओके, व्हेन दे ब्रेक दिस कॉन्टैक्ट, नो इसको वो हिट करेगा ना, ऐसे आगे पीछे होगा, तो जो नीचे वाला जो बॉल है ना वो जाके आपकी बेल को कभी जोर से हिट करेगा. ठीक है, टू एंड फ्रो मोशन दिखाएगा. एंड दिस स्टॉप्स द करंट, डिस्ट्रॉइंग द मैग्नेटिक फील्ड. सो द स्प्रिंजी, फिर उसमें क्या होता है, जब आप करंट स्टॉप कर देते हो ना, उसकी लाइट ऑफ हो जाती है, आप उसका स्विच आप निकाल देते हो, तो उसमें करंट फ्लो करना रुक जाता है. फिर आपका सर्किट वापस उसी पोजीशन पे आ जाता है. फिर जब आप उस बटन को प्रेस करते हो स्विच ऑन करके, तो वो वापस वही से सर्किट ब्रेक होता है और बेल रिंग करना स्टार्ट कर जाती है. क्लियर मोहम्मद, सॉरी आयान?
Yes.
Do you have any question?
No.
So I think everything is clear here, is it?
Yes.
So far so good.